Well, hello, good afternoon. We are Alayo, staff engineer in user testing, and Sergi, Rosell, senior DevOps engineer in user testing too. Today, we will talk about security, but first we want to explain to you what user testing, and you probably don't know, and why we care that much about security. Then we will get deeper in infrastructure as code and CI/CD and GitOps. Then we will tie it all together in a beer tie of it all. And finally, we'll get into the next steps and see there what are the things that we still need to figure out and learn even more. No? So user testing is a company in the UX market that helps other companies, so their customers, to improve their platform, right? User testing is the leader in the UX market in the whole world. For example, we have 75 of the Fortune 100 companies as a customer, so you can understand that with that, the data that these customers produce in our platform need to be really secure and all that. So yeah, here you can see some of the logos that we have as a client, as a customer. You can see here some that need more security than others probably, but most of them are enterprise companies, so they need a level of security enough so they can operate with us. So once we already seen what user testing, really quick introduction, let's try to explain a bit better the use case of the company. Right. First of all, what user testing does, what our SaaS software does. The SaaS software starts with the customer creating a study, right? And then with that study is distributed to the participants. The participants participate into that study and answer all sorts of questions and tasks. All this data is gathered by our system and aggregated, analyzed, and shown back to the customer so they can take any sort of decision that they see fit, right? So here I would like to highlight two parts on the security aspect. One is the participants' data, right? Participant data here, they can answer all sorts of questions and do all sorts of tasks that are sensitive data, basically. So we need to have a good level of security because of that. But in the other side, and even more important, as we already said, right, we have top brands in the world. So the data that it's here, it's used to make actual decisions on their software, and it impacts them in millions. So we need to actually secure their data very well because we even have competing companies, no? So there cannot be any leakage of information and things like that, no? So once we explained a bit more how user testing works, this is how it looks like a bit inside. We have different sub-platforms, no? One for ingestion, one for creating the test, the other that distributes the information, etc. No? So you can see here more or less the number of microservices that we handle. It's not a big number, but it's also not tiny, no? And the company keeps growing. So, and as you may know, microservices development is closer to infrastructure, so it cares more about infrastructure, and it needs to make more changes about infrastructure, right? And below you can see there some of the technologies that we use, just so you understand that we are a bit all over the place. All these microservices use different technologies, different databases, etc. So with that in mind, and these are the security standards that we cover today. You can see the badges in the site. I would like especially to, they are pretty standard, I would say, probably for any company that it's big enough, but I would like to highlight the accountability and audit logging. Accountability and audit logging, first, when we talked about it, I personally, I thought that it was, the production environment has who did what and when, no? But this actually is not only about that, it's also about the process of getting the code and getting the infrastructure to production and seeing who did what, when, and with which permissions, and who actually decided that this could happen or not, no? And also that nobody can do that alone, and things like that, no? So I want to highlight that because we'll talk further deeper on this aspect of security. So the use case at hand and why we are today here is that, okay, so we use Terraform, right, to create all the infrastructure. We had a good knowledge of it already with best practices, security, etc. But it was a niche use, right? It was only used by the infrastructure and ops team. And they did a pretty good job, but the company keeps growing, so the company felt the need to enable all engineers to actually use Terraform to build their own infrastructure. But then if you compare it with all the security standards and these engineers not knowing infrastructure, then you have a problem, right? So what we did is trying to find a process that actually allows for these two things to happen, right? One, comply with all the security standards that we have, and the other one, enable developers to take ownership and own their own infrastructure, be able to change it, remove it, add it again, etc. No? So we'll get deeper into it, and Sergi will explain the infrastructure code.
Thank you, Rock. Well, so we will start talking about a little bit of the objective of why we have infrastructure as code. You see here different kinds of requirements or requests that we had. We would like to focus, as Rock was saying, about one of the key points was increasing the efficiency in the software development and improving the accountability for the whole company. So before going a little bit into the actual structure and code, I would like to highlight some concepts that will be mentioned during the presentation, so we are all aligned. We've decided to divide the platform and the code in these three concepts. Capsule, which at the end is a platform. A capsule, an environment is an instantiation of a capsule, which then can have different regions, for example. And then layers, which are the sub-platforms that Rock was talking at the beginning, having different number of microservices, that altogether forms the SaaS. Initially, part of the security concerns was, OK, we need data isolation, and we achieved that by having each capsule and environment in a single independent account. Each environment can hold different regions, so all the regions are in the same account, but each environment is isolated by default. Also, any access to the resources is always made via AWS SSO users, the developers itself, or any application uses always IAM roles. So there are no static credentials anywhere. And now, starting with the actual code itself. We've took the decision to go with a monolithic repository. This brings us a single source of truth for the whole infrastructure in the company. At the beginning, we had code spread around some places, and this make quite difficult to know what we had and from where it was coming. It also allows us to have a unified single CI/CD flow for the whole infrastructure of the company. And also, again, as one of the key points, have accountability for who is doing what, when, who approves it, and also helping the rest of the teams to have examples and see what the rest of the teams are doing. This is a little bit a picture of how the repository looks like, and now we're going to go deep in each of the folders. One of our main focus as an ops and infra team, as Rock was saying at the beginning, to allow the rest of the colleagues to work efficiently, was to have some good models that follows all the security practices that we were requested by the security team, enforcing tagging, naming conventions. So at the end, what we have is a strong opinionated version of the models, which at the end, one instantiation of one model looks like something like this. So a developer can deploy any resource that he needs for his application without having to have deep knowledge on the infrastructure part. But to accomplish that and be sure that we don't have any issues, we also are testing those models. So once we deploy them, once we develop the models, we gather some use cases, and then we use that to test that we don't do breaking changes, to ensure that the security team is aligned with what we are configuring, and also we realize that it is a pretty good way for the developers to know how they can use the models, because they are like live examples of deploying infrastructure with them. Sorry. So coming back to the capsules, which at the end is the infrastructure that we're deploying really, we have 3 capsules for now, networking, engineering, and runtime. Now we are going to go deep in each one of them. Networking, it holds, obviously, all the networking-related centric points, transit gateway, IPAM, VPC peerings, or whatever. We're having centralized NAT gateway, so we can inspect the traffic in that sense. That's also handled here. Then we have the engineering capsule, which holds all the internal resources that we need to be able to develop our code. For example, ArgoCD, GitHub self-hosted runners. And then, at the end, the runtime capsule, which holds the SaaS platform. As you can see, the structure of each of the layers, so core is a layer, then each team should have his own layer. All the structure inside of those folders is kind of similar in all the capsules. That was one of the key points into trying to standardize the process. And then we're getting used the Terraform workspaces to be able to personalize and customize any environment. So with that approach and also the help of the makefile, which looks a little bit like that, we get Terraform files, some TF bars that allows us to personalize the values of each environment, but forces us to have the same resources deployed in each environment, so we don't have drift in the environments. All this picture holds in a workspace that then gets deployed into a AWS account and region. And this is just a bird's eye picture of what it looks like. The pink capsules are the capsules. So on the left side, the engineering one. On the right side, the runtime. That just simply exemplifies a region with Kubernetes. On the right side, the infrastructure services that we're using from AWS. On the left side, ArgoCD to deploy the microservices. But OK, now this is the infrastructure that we have, how we handle the deployment of those changes. We have 2 similar pipelines, but different, one for the modules and one for the capsules itself. Again, the idea of standardization and accountability, this is what helps us to have all these in place. For the modules, we have when a PR gets made into main, and we always work against main. We first do some checking, format, static checking, security checkings. We're using Trivy for that, for example, where we have some compliance policies configured over there. Then, if all those checks goes green, we use the modules test that we said before to kind of ensure that we're not breaking anything. And for now, that gets to merge, that gets merged to main, and that should be it. We're working on having some versioning for those modules so we can improve the stability of the platform, but for now, this is a little bit how it looks like. And this is, again, the pipeline, but for the capsules. As you can see, the first checks are kind of the same. When we arrive there, we do a plan, and the plan gets pointed to the PR. For now, this is what we are using. As you may know, the TF plan output is not really great, so we are working in a way of trying to summarize and improve the visualization of the change to allow anyone in the company understand easy what that change is doing and be able to approve it or not in that sense. Then, if everything goes well, that gets merged into main. And then, for now, we are applying manually the changes. We're waiting for the teams to be OK with the flow and be sure that everybody is comfortable. But our idea, again, and we are working on it, is to at least automatize the applying into dep and staging environments. And for production, we have still discussions internally to do. There are mixed feelings about that. OK, and now, this was for the infrastructure. Rock is going to do the application flow.
Thank you, Sergi. So with that, we explain infrastructure as code, and all the CI/CD around it. But as you may know, as a software is not only infrastructure, right? Although we are in an infrastructure conference. So the application CI/CD, I think we thought that it was important to show too, right? And the objective that we want to accomplish here is transform somehow changes in code directly into versions in Docker images, Argo, and Helm, right? We finally decided to take leverage on conventional commits. For the ones that don't know what it is, here there is a sort of the structure of a conventional commit that with the type you can decide the type of change that you do in the same version, right? So this is what we will talk about on how we build that to work, right? So first of all, tag generation. Any change into our code base, right, happens to pass different checks, similar to the ones that Sergi already explained. But when things get interesting is when we merge to main, when we do a PR to main, right? In these PRs to main, since we just have trunk-based development, so we don't work with branches, when you merge the PR, we auto-generate a changelog, and we tag the repo with the new SEM version. Here you can see some of the examples of the pipelines and the changes in the code, etc. This and also below you can see that we check the name of the PR also. That's because we use it's called stash and merge, Squash and merge, thank you. So the name of the PR is actually the conventional commit that will get into main. So we check that with another GitHub action. So once we get, this is the second step, right? We already got the tag into main, and now we need to push it somewhere. What we do is build the image with that tag name. We upload it into ECR, and then we push it also into changing automatically the Helm chart, basically, which is the examples that you can see below. One is front-end, and the other is one back-end service. And you can see the upgrade of the version there. this is done automatically by the CI, and then ArgoCD, thanks to GitOps methodology, gets those changes, moves them into Kubernetes, and Kubernetes rolls out the new version, right? So with that, we get into the last step of it all, which is, OK, we have the changes automatically deployed in every commit into the development environment, but how that gets into production, right? Well, we haven't automated everything, because here is a manual trigger, for now at least. But the idea is that we build this automation that what it does is compare the two versions that you are trying to deploy. So compare development service versions with staging service versions, or staging with production versions, and decides on the services that need to be updated, right? And creates a PR with it. Below you can see sort of the two examples, the code that it changes in that PR, and the description, right? This description is a scraping of all the change logs, and we put it together in a script, and it creates the description of the PR. No? So this PR is useful to check whether or not these changes were have to happen, or somebody merged something that they shouldn't have merged. Is another level of checking that we can have. No? And again, when you merge the PR, the changes are detected by Argo. ArgoCD deploys the new deployment into Kubernetes, and Kubernetes rolls out these changes in time. No? So with that, we tied together the two parts. No? So here we have sort of an schema of the two things. Basically, for one side, infrastructure as code that has their own processes, their own CI/CD, which enforces security and best practice into that code and into that infrastructure. And in the other side, application code that also has their own CI/CD that enforces this security and best practices on that code. No? And all together comes into Kubernetes or the infrastructure to create or SaaS software user testing. No? So again, we talked a lot about security, or bits and bits there. So here is a slide as a summary of it all. No? So we can understand where we applied every one of the standards that we set in the first slides. I would like to highlight here what Sergi already explained, the opinionated TF modules. They are working really well for us. It's really easy to use and really easy to own that code, because you don't really, as an engineer that is not a DevOps engineer, you don't need to really know about the security and the KMS keys and whatever security is there. You just use it, and it works generally. No? And the other part, the traceability again. No? All this CI/CD that we created around may seem, too much probably for maybe someone, but it gives us a lot of traceability on who did what and when, and with what approvals. No? In these PRs that we shown, we could potentially not let merge some people the PR and some others yes, or approvals for one type of person give them ability to merge, etc. No? And with that, we get to the next steps. So in next steps, we still have a lot to learn. We are not experts. We are just showing our use case here and how we did everything. And yeah, so I would like to highlight here Helm chart management. You probably noticed that we didn't talk about it, because basically for now, we have it, of course, but we don't have versioning on there because Helm chart versioning is easy, but Helm chart values versioning is not. And since we still didn't figure out exactly how to do that, we are still trying to come up with ideas there. If you have some, please do let them know to us afterwards. And the other one that I would like to highlight is the Terraform test new functionality. No? That's kind of really new, no? 2 weeks, 3 ago maybe. And although we have a custom test framework, we need to check this, play with it, and see if it fits our needs, and then be able to maybe change it altogether for the one that we are already using. No? Well, that was it. But before we finish, here there is a URL that you can be a tester in our platform if you want to. As the URL says, you get paid for it. So that's nice also. And also, thank you all the user testing colleagues that help us put together this presentation. And thank you for listening. So yeah.
Thank you.
Wow, you went quick. So yeah, we have many questions as it was expected. So let's try to cover them all. The first one, it was inevitable. You showed Istio, even if briefly. Can you explain what problems is it solving for you?
OK, so for now, we are using Istio for gRPC balancing in the Kubernetes cluster and mTLS. That's the main usage that we are doing it for now. We are not pretty sure about keeping Istio. Maybe we shift it to other things. But for now, it's the main usage that we're using it.
OK, then there were a number of questions around testing the Terraform modules. Can you explain how they are actually tested? If they are using, some particular, I don't know, library or like?
We give a thought at using TerraTest, for example, which is a Go library to test Terraform. But for now, what we're using is essentially instantiate and deploy actual infrastructure in a testing account, where with configurations on the modules that fulfills our use cases or needs. And then after deploying it, just delete that infrastructure. If it goes well, the test is OK. If it breaks something, we have to fix it. That's also one of the things that we want to have a look at the new test functionality in Terraform, because you can put some contract testing, some pretty nice things, at least it seems. So.
Someone is saying that they developed a very similar folder structure, like the one you showed. And they're asking if but that they did it like before, so after asking ChatGPT. And they're asking if we, because I was part of the project, did the same, or it was something else to achieve that.
Well, no, we didn't ask to ChatGPT. It kind of is a mix of a little bit what we had before, a little bit of reading out best practices from, I don't know, the rest of the world, let's say, and also trying to focus a little bit on on the requirements that product gave to us, which was we want to have an easy setup of a new environment, because if we need to spin up a new environment, they wanted to have it fast and easy. So that was one of the key aspects on part of the structure at the end.
And they're also asking where and how the Terraform pipelines are run and how the Terraform states are managed.
OK, so state, we are managing in S3 buckets and Dynamo for the locking. The pipelines are run in GitHub because all our code base is hosted in GitHub. So it is essentially GitHub pipelines.
OK, about the monorepo, they're asking OK, how do you manage new versions of the modules and how they are applied in different environments to ensure that it doesn't break when changes happen?
OK, as said, this is still a work in progress. Our idea is to try to follow a little bit the, for example, JavaScript approach with monorepo. So having different tags with, I don't know, the name identifying to which module that tag references from the changes, and that's kind of it. And just PRs, versioning the new with Semver or something like that if we can.
Yeah, they're also asking, yeah, there were many questions. Yeah, so about the pipeline checks, they're asking like if we also do, well, I'm saying we because it's kind of weird, this one, okay? If we also do code reviews and how the GitHub repos are managed, more or less, so that they are more or less with the same constraints.
Well, yeah, in terms of Terraform code or application code, we kind of follow the same pattern. We do need revisions in each PR, depending on the repository and the team, 1, 2 people, depending on the team, some groups on GitHub which holds, for example, some more senior colleagues on the team or less. Basically, we are forcing also that the pipelines needs to run successfully to be able to merge the PR.
Yeah, for example, the ownership of each layer is to each team, right? So in the pipeline review, it would be, of course, the infrastructure and ops team, but also the team leads maybe, or the team experts of that layer could be the ones reviewing it. You know? And then they don't care about the other team's layer and what they do and how they do it.
So at the end, we benefit from the code owner's file in the repository to filter by path or something. So some paths or some modules are also owned by security. So if we are changing something, for example, in the KMS module, they just get notified and they have to approve it before anyone can merge that.
And the final one, so you did a very good job answering them. And they're asking, like, how do you manage your AWS landing zone to make sure all accounts are compliant if you are using Control Tower, which, yeah.
Yeah, we are currently using Control Tower. I have to say that we don't have it in a pretty mature state. We are basically using some SCPs to configure allowed regions and allowed services, but for now, it is in a pretty basic state. We are working close together with security, which we didn't see it in the presentation, but they are currently setting up a new capsule for all the security code related to be able to also manage it via Terraform.
Okay, and there was one other question that they were asking about if you could show some slide, but rest assured all the talks are recorded, so you will be able to see it multiple times at home, so don't worry about that. Just bear with us. I think in 2-3 weeks, depending on Stevie, who is recording over there, we will see. But yeah, all the talks will be published, so yeah, and potentially the slides as well, if you can bring them
yeah, sure.
to us, we can publish them, so you will be able to see it. All right, thank you very much, folks. It's a pleasure to have you, so thank you.
Thank you.